Section 7.7, complex numbers. Remember we had the square root of 4 was equal to 2. But what about the square root of negative 4? Square root of negative 4 is like the square root of 4 times negative 1. You know, if you have a product under the radical sign, you can split it and write it as a square root of 4 times the square root of negative 1. So many moons ago, mathematicians decided what? To call square root of negative 1 I, and I stands for imaginary unit, right? So it's imaginary number. So what does it mean for a number to be imaginary? So it means it's not a real number. So there is no graph or picture on a number line. It's not like, you know, um, a number out of imagination. It's just like there's no picture on the of what? Of the complex number or imaginary number on number line, but it's very useful number in real life, even though it's imaginary. It's used in many aspects of life, such as engineering, science, and so on and so forth. So back to a square root of negative 4. So that's a square root of 4 times the square root of negative 1. Mathematicians decided wherever they see square root of negative 1, so they can replace it with what? With I. So that's why the answer for square root of negative 4 is 2I. So now we have a brand new classification of numbers. So up to this point, we were using real numbers. Now in this section, we'll be dealing with complex numbers, which deals with what? Imaginary numbers, such as square root of negative 9 is 3i, square root of negative 25 is 5i, square root of negative 64, 8i, square root of negative 110i, square root of negative 17 is 17 times negative 1, but you can split this, but this guy is I, so the answer is square root of 17i. Notice I can go in front of the radical or right here, but not under the radical. Make sure you don't put under the radical. In other words, the answer is not like this, okay? Be careful. Square root of negative 24 is square root of 24 times negative 1. But this 24 is 6 times 4, which is 2 square root of 6. And remember, this guy by definition is I. So it's 2 square root of 6i. Now, be careful. When you have cube root and a negative number under the radical, you have a number, you have an answer. This is not complex. Cube root of negative 8 is negative 2. Cube root of negative 27 is negative 3. Fifth root of negative 32 is negative 2. These are real numbers. They are not imaginary. However, the fact is, when you have negative number under a radical whose index is odd, you have an answer. But if you have a negative number under the radical, index is even, then we have an imaginary number, yes? So what's a complex number? Complex number is denoted by capital Z. It's a number which consists of two parts, namely real part and imaginary part. So it's shown as a plus bi, or sometimes a minus bi. And these forms, these two forms are called what? Standard forms, correct? So A is the real part of the complex number. B is the imaginary part of the number. So the constant with no I attached, it's called real. The coefficient of I is called what? Imaginary part of the complex number. So in this case, we have a bunch of complex numbers which consist of real and imaginary. The question is, can you identify the real and imaginary part? The real is 3. The imaginary part is positive 3. Do you see it? Here, the real part is negative 1. The imaginary part is negative 5. Here, be careful, you got to write this in a standard form. Real goes first, followed by imaginary. So the real is 11, imaginary is 6. Here, this is the same as 0 plus 17i. There is no real, but imaginary is 17. So this is called pure imaginary. This guy is real, which is 23 plus 0i. So real part is 0. And what? Imaginary part, real part is 23, imaginary part is 0. So this is called a real number, whereas this is called pure imaginary. It's 100% imaginary. In this case, the real part is 1/2, the imaginary part is 1/3. Here, you need to split the fraction. I write it as 5/4 minus 7/4i. The real part is 5/4, the imaginary part is negative 7/4. Here, the real part is what? Not, so write this in a standard form, which is the same as 9 minus 2/5 I. So the real part is 9, imaginary part is negative 2/5. Be careful. Make sure this guy is in standard form. Standard form is A plus BI. A has to go first, which is the real part. B is the imaginary part, correct? So now, how do you apply the four basic operations on complex numbers? That means adding, subtracting, multiplying, and dividing, correct? To add or subtract is easy. Just look for reals and combine them. Look for imaginaries and combine them, just like combining the like terms. So 3 plus 4 is 7. 2i minus 5i is negative 3i. There you go. That's what you get when you add these two complex numbers. What about subtraction? Well, first, distribute the minus. So you get what? Positive negative 6 minus I. So this negative changes the sign. Now look for reals and imaginaries and combine them. So that will be 3 minus 9i. Final answer. How do you multiply complex numbers? Remember, by definition, I was the square root of negative 1. But if you square both sides of this equation, remember the 2 cancels the radicals, so I squared is negative 1. So keep that in mind because that's what I'm going to be needing to replace the I squares with negative 1. So check this out. So if you distribute this, remember I'm multiplying a pure imaginary by complex number. So I get what? 6i plus 12i squared. 6i plus 12i squared. But remember, wherever we see I squared, we're going to replace it with negative 1. So that's going to be like negative 1. So the final answer is negative 12 plus 6i. So be careful. Every time a number is attached to the I square, the sign of that number changes. Why? Because I squared is equal to negative 1. How do you multiply these two complex numbers? Well, remember we can use foiling. So this would be 1 minus 5i plus 5i, what? Minus 25i squared. But these guys cancel, so you get 1. Remember, I'm supposed to replace this with negative 1, so that's negative 25 times negative 1, which is 1 plus 25, so the answer is what? 26. Do you see it? Right? So that's positive 25, right? And plus 1, and these guys cancel, so you get 26. What about this guy? Once again, I do foiling. So I get 8 plus what? 2i minus 28i minus 7i squared. Remember, I squared is negative 1, so negative 1 times negative 7 gives us what? Positive 7. Remember, this guy is negative 7 times negative 1. Why? Remember, I squared is negative 1. So combine the i's and combine the reals, you get 15 minus 26i, correct? Sometimes the problem shows up like this. So first you have to convert these guys to i's. So that would be like 2 plus 2i, and this is 3i, and that's minus 5. Right? These are imaginary numbers. So once you convert the square root of negative numbers to I, then you are ready to combine. This is about adding, not multiplying. So you add these guys, you add those guys, the reals and imaginaries, you get negative 3 plus 5i. Okay? Then there is this topic of conjugate, that's C-O-N-J-U-G-A-T-E, conjugate of a complex number. What's a conjugate of a complex number? which is denoted by z bar. So the conjugate is the same complex number originally, but you got to change the sign of the imaginary part. In other words, the conjugate of 2 plus 3i is 2 minus 3i. The conjugate of 1 minus 6i is 1 plus 6i. The conjugate of 5i minus 7 is not 5i minus 7, is not. First, you got to write this in a standard form, which is 7 plus 5i. So its conjugate is 7 minus 5i. Remember, we only change the sign of the what? Imaginary part, not the real part. What is the conjugate of 6i is negative 6i. What's the conjugate of 17? 17 doesn't have a conjugate, so real numbers don't have a conjugate, yes? What about conjugate of negative I is positive I. Conjugate of 1/2 minus 1/5 I is 1/2 plus 1/5 I. And conjugate of 6 over 7i is negative 6 over 7i. So the question is, what's the purpose of the conjugate? Well, we need the conjugates to divide complex numbers. So remember the objective of division of complex numbers. Objective is what? To eliminate I from the denominator. So this is the objective of dividing complex numbers, correct? So what do? You guessed it. You multiply top and bottom by the conjugate of the denominator. The conjugate of 3i is negative 3i. Remember, the objective is eliminate I from the denominator. The minute I disappears from denominator, then the mission of dividing complex number has been completed, right? Mission accomplished. So what do we have? On top, I get negative 12i. Bottom, I get negative 9i squared. But keep in mind, I squared is equal to negative 1. So this guy is what? Negative 9 times 1, negative 1. And this guy is what? Negative 12i. So that's negative 12i over 9. But I can reduce these guys by 3. So that will be 4i over 3. So there you have it. Final answer. Notice no I at the bottom of the fraction. Therefore, the mission accomplished. That's what they mean by divide. Just like radicals. When we divided radical, the objective was to eliminate what? The radical term from the denominator. So we called it rationalization. So here we multiply top and bottom by conjugate of denominator, which is negative 2i. Bottom we get negative 4i squared. On top I gotta multiply negative 2i by these guys, so I get what? Negative 4i minus 6i squared. But once again, don't forget, wherever you see I squared, replace it with what? Negative 1. So on top you get negative 4i plus 6. Here you get positive 4, because remember, that's negative 1 times negative 4. So if you kind of put the top in the standard form, you get this. Now if you split the fraction, you get this. Now, if you reduce the fractions by, let's say here by 2, you get this. And here you get 1. So now the final answer is in standard form. Do you see? So the real part is 3/2. The imaginary part is negative 1. What about 3 over minus 2i? So what you do is multiply top and bottom by conjugate, which is 1 plus 2i. In the denominator, you get 1 plus 2i minus 2i minus 4i squared. On top, you multiply 3 by 1 plus 2i, you get what? 3 times 1 plus 2i. Let's see what we get at the bottom before I distribute the 3. These guys cancel. They should always cancel the middle terms. This guy is negative 1. Negative 1 times negative 4 gives you positive 4. So the answer is 3 times what? 1 plus 2i over 5, which is 3 plus what? 6i over 5, which is 3/5 plus 6/5 I, standard form. Real part is 3/5, imaginary part is 6/5. This guy, you multiply top and bottom by what? Conjugate of the denominator, which is what? Which is 4 minus 2i. Okay, let's do the denominator, which is what? 16 minus 8i plus 8i minus 4i squared. And the top is 6 minus 3i times 4 minus 2i. Let's multiply the tops too. That's 24 minus 12i minus 12i plus 6i squared. These guys cancel, and don't forget I squared gets to be replaced by -1. Okay, so this guy becomes what? -6. So on top I have 24. Add the i's, you get -24i minus 6. This guy becomes +4, so that's 16 plus 4. So if I add the reals, I get what? 18 minus 24i over 20. Is that right? And what? If you split the fraction, write it as 18 over 20 minus 24 over 20i. Reduce the fractions to the lowest terms, say right here by 2. That would be 9/10. Here by 4. That would be 6/5 I in a standard form. Do you see it? So the real part is 9/10. The imaginary part is -6/5. Finally, 7i divided by 5 minus 6i, you multiply top and bottom by the conjugate. Okay, so on top, I get what? 7i times 5 plus 6i. At the bottom, I get 5 minus 6i times 5 plus 6i. So if you distribute the top, you get what? You get 35, what? I plus 42i squared. At the bottom, you get 25 plus 30i minus 30i minus 36i squared. Keep in mind, every time you see a I squared, replace it with -1. So on top, I get what? -42, this guy, plus 35i, that guy. At the bottom, these middle guys cancel, and this guy becomes +36. So +36 and 25 is 61. Is that right? So now if you split this, you get -42 over 61 plus 35 over 61i in a standard form. So the real part is -42 over 61. The imaginary part is 35 over 61. I hope that helps. Thank you.